Hi, this is Rabat Khan, and in this lecture, we'll try to solve the Lab 1 Task 3 problem. So before getting to the solution, let's read the question. The question says, you'll be given n number of students' marks and their corresponding IDs, and your job is to sort the marks in a descending order. Now, if multiple students get the same mark, you have to sort them according to their IDs. The ID with the lower value will come first. Now, let's look at the example. We have the input on the left-hand side. The first line of the input is the number of samples. The second line of the input are the IDs. The third line of the input are the marks. Now look, if we look at the output, we see that the largest marks, 50 in this case, come first. So we have two 50s. Now if I look at the IDs, the ID 4 comes before the ID 9. Again, we have 40, 20, and again we have three 10s. The lowest ID comes first. I hope you've understood the problem. Now let's get to the solution. Well, in this lecture, I have tried to solve the problem using the very basic data structures, and those are linear arrays and a matrix. I have not used any dictionary or any advanced data structures or ADTs. So the best effective. Oh, by the way, before I get to the solution, there's something we need to focus on, and that is this bold line. It says we have to keep in mind that we have to choose a sorting algorithm that has a minimum number of swapping operations. So considering everything, the best sorting algorithm that I've thought of is COUNT-SORT. Now, COUNT-SORT is effective when the range of input is narrow, and COUNT-SORT can only be used if the elements are integers. Now, these two properties perfectly match with the problem we are working with. We have exam marks which do have a narrow range and they are integer values. COUNT-SORT works on the frequency of the input values, and the best thing about COUNT-SORT, I think, is its time complexity, which has a linear time. Now, the main puzzle with this problem is we have to also take care of the IDs when we have students scoring the same marks. Now, let's get to the solution. Okay, first we have the number of samples, and let's denote this by n. And then we have the IDs and the corresponding marks, and let's say they are two separate arrays, ID and mark respectively. So let's say we have a sample containing 5 marks and IDs, so n equals 5. So we have these IDs over here in an array named ID, and we have the marks over here in an array named marks. So the first step of COUNT-SORT is to find the maximum mark. So we are dealing with mark because that's the primary input. So from the marks array, the maximum mark is 5 in this example. And the time complexity to find the maximum from a linear array is big O of n. The second step is to create a matrix. Let's call it mat. And the dimension of the matrix will be max plus 1 and n plus 1. So max plus 1 is the number of rows and n plus 1 is the number of columns. So we have 5 as the maximum number. Therefore, there will be 6 number of rows. Let's count it. We have 1, 2, 3, 4, 5, 6 number of rows, and we have 5 samples. Therefore, we have 6 number of columns. By the way, the matrix we have just created is an integer matrix. Therefore, all these cells have zeros initially. Now, in the step 3, we run this loop. This loop is for each m and I, from the marks and ID arrays, we do this three operations. M and I are the values from these arrays. So let's create two tables, or I create one table and create columns, one column for M and the other column for I. So the first pair of M and I are 4 and 6, 4 and 9. 4 will sit in M and I will sit, and 9 will sit in I. Now we will be working with this cell M0. M0 is 40, that is row number 4 and column number 0. So this particular cell. And what we do is we simply increment this with 1. So as this is an integer matrix, the initial values are 0. So when we add 1 with the 0, we get a 1. And then we have another variable x. So let's create another column for x. X is nothing but the value of this cell M0, which is this one. So let me write 1 over here. Then what we do is we go to this cell MX, that is 4, 1, and that's this particular cell, and we store I over there. I is 9, so we store 9 over here. So we are done with the first pair of input. Then we will be working with the second pair of input. Let's cancel them. So we have 5 in M, and we have 6 in I. Again, do the same three operations. We first go to this cell, M0, that is 50, this particular cell, and add 1 to it. So this becomes 1. Then we save whatever we have over here at M0 to X. So 1 sits in X. Finally, we go to the cell MX, that is 51, which is over here, and store 6. So let's store 6 over here. So we are done with the second pair of input. Now we'll be working with the next pair. We have 5 again as M. We have 8 and I. We go to this cell first, M0, that is 50, which is this particular cell, and add 1 to it. So we have 1, and if we add 1 to it, we get a 2. So let me erase this 1 and put 2 over here. Then we store this value we just updated and store it in X. So we store 2 over here. And then we go to this cell MX, that is 52, this cell over here, and store I, which is 8. So we will be doing the same or applying these three operations on every pair of input, and at the end we'll get something like this. We'll have 3 over here, and we'll have a 5 over here and a 7 over here. Okay, so this is at the end of working with all the pair of inputs. Now if you look carefully, the 0 column or the 0th column stores the frequency. of this number, of this mark. Now I have used the row number as the mark. Okay, so we have 1, 2, and 3 fours. So we have a 3 over here, and we have 2 fives. Therefore, we have a 2 over here. And these numbers are the corresponding IDs. So the students scoring 4 are 9, 5, and 7. So we have a 9, 5, 7 over here. And students scoring 5 are 6 and 8. So we have a 6 and 8 over here. You see 9, 5, 7 are in the row, in the fourth row, and 6 and 8 are in the fifth row. Okay. So this matrix stores the frequency and also the IDs of the students. Now the step 4 is we have to find the cumulative sum. Now let's run this piece of code over here, then we will understand what cumulative sum means. First, we have a variable called x. So we have a column named x over here. And the initial value of x is max minus 1. We know max was 5, so max minus 1 is 4, so we have 4 over here. Then we run a loop while x greater equals 0, which is true. Then we do something inside the matrix. Inside the cell x0, that is 40 over here, we do some work. And the work is pretty simple. We add whatever we have just below this particular cell and add with the value of this cell and store it over here. You see, it's mat x0 plus equals mat x plus 1, 0. So we first go to mat x0, which is 40, and we get a 3. Add mat x plus 1, 0, which is mat 50, which is 2 over here. So we do an addition, 3 plus 2, 5, and we store 5 inside x0, and that is over here. So this 3 will get replaced by 5. So this 3 gets replaced by 5. So what we are doing is, if we are working with this particular cell, we will add the value of this cell with the cell right below it, and the sum of these two values will sit over here. Then we decrement x, so x becomes 3. So for this cell, we do the exact same thing. Right now we have 0 over here, and right below it we have 5. 0 plus 5 is 5, and we store 5 over here. Similarly, we do this for every cell, or every cell of the first column only, okay? So we have a 0 over here initially. 0 plus 5 is 5. We put 5 over here. And all these cells will be 5. So this step basically guarantees the sequence of the numbers in the marks array is maintained, okay? So if we look at the marks array, this mark came first, or this 4 came first, this 4 came second, and this 4 came third. This step, what we just did, make sure that this sequence of numbers or the sequence of repetitive numbers is maintained. Okay, we will see how this works. So after we run this step, the final output we have is we have the cumulative sum on the first column or in column 0, and we have the IDs following the sum. So over here we'll have the sum, not the frequency. Now this is step 5. We have to create two output arrays of the same length as n, and one for the marks and one for the IDs. So we have created two arrays. One of them I've named out ID, and the other one I've named out marks. So as you can see by the name, this array will have the marks in sorted order, and this array will have the corresponding IDs. Now it's time to sort. Now this is the algorithm for sorting, okay? For each mark M from marks, so M, let's create a column for M. And the first M is 4. This is 4. We have F. Let's create a column for F. We have mat M0 stored in F. So mat M0 is nothing but mat 40, which is 5. So let's put 5 over here. Then outmarks, this is outmarks, F minus 1. So inside outmarks F minus 1, that is, F is 5. So F minus 1, 5 minus 1 is 4. So inside this particular cell, we will put M, and M is 4. And then inside out ID F minus 1, which is this cell over here, out ID F minus 1, which is 5 minus 1, 4. What we do is we call a function extract mean ID, which is basically what we want is from these IDs over here from the matrix, you extract the minimum, okay? So these are the arguments. So mat M1 is basically you start from this particular cell, and F is the number of elements you have. So you need these pieces of information in order to extract the minimum ID. So we have three IDs over here, 957, and if we call the extract mean ID function, we get 5, okay? And this 5 will sit over here. Okay, I made a mistake. Uh, okay, the mistake is not very big. It's a very small mistake. So instead of extracting the min ID, what we do is we extract the max ID. Okay. So instead of min, we extract the max ID. And among these IDs, so out of these IDs, 9 is the max. So what we do is we put 9 over here. And when I say extract means you erase it after you're done working with it. Okay. Then after extraction of the max ID, what we do is we reduce the count or the frequency. At M0, that is 40 over here, it was 5, we make it 4. So we have done working with the first mark. Now we will be working with this 5. So M will be 5 now. F will be M0, that is 50, which is 2. Out marks F minus 1. Out marks F, which is 2 minus 1 is 1. This particular cell will have M, which is 5, and out ID F minus 1. This is out ID, and F minus 1 is 1. And inside this particular cell, we have the maximum ID among these IDs, 6 and 8. So as we are working with the mark 5, we will only look at the IDs of students who have scored 5. So out of 6 and 8, 8 is the maximum. So we extract 8, and that is we put 8 over here, and then of course we remove it. And finally, we decrement the count by 1. So it's 2 over here, we make it 1. So done with the second input. Now we have a 5 again. So M's 5 again. F equals M0, that is 1. Out marks F minus 1. Out marks 1 minus 1 is 0. That is, this particular cell will have 5. And out ID 0 will have the maximum ID. So there's only one ID remaining, and that's 6. So we simply put 6 over here and remove it because we have extracted it. And finally, decrement the count. So it's 1, it was 1, so make it 0. Done with this 5. Again, we see a 4 now, so M is 4. Out marks F minus 1, and F is 4 also. F is nothing but the frequency or the count of the mark. F minus 1 is 3. So out marks index 3 will have 4. And out ID index 3 will have the maximum ID between 5 and 7, which is 7. Remove 7. And then decrement the count. So from 4, make it 3. Finally, for the last input, you put 4 over here, and you put the remaining ID over here. So we have our output. So if we look at the out marks, we have the marks sorted, in descending order. And if you look at the out ID, we have the ID sorted for those students who have scored same marks. Students with ID 6 and 8 have scored 5. So 6 is smaller than 8, so it came before 8. And 3 students scored 4, and they are sorted according to their IDs, the smallest first. Now let's find out the time complexity. So for step 1, it's big of n because we have to find the maximum. For step 3, we just have to populate the matrix and from the input. Therefore, this loop ran for big of n times. This cumulative sum, this loop also ran for big of n times. Or more likely, this ran for max plus 1 times. Which is linear, by the way. Finally, this loop over here ran for n times, and this particular function extract max will also run for n times. So for every mark, we had to extract an ID. Therefore, over here, this took me n squared. So the final time complexity of, by the way, for count sort is n, but as we are dealing with two arrays together, the final time complexity of this particular solution is n squared. Now, if we had used heap sort, something we will study later in the course, we could have reduced the time complexity significantly, okay? And this, if we had used heap sort, the time complexity would be something like n log n, which is a lot less than n squared. All right, that was it. Thank you very much.